Hi, in this video, we are presented with a system of equations where we are required to find x, y, and z such that x, y, and z are all elements of integers. So basically, we're looking for integer solutions. So what we can do from here is, well, let's analyze what we have so far. So we have x squared plus y squared plus z squared is equal to 19 squared. 1 over x plus 1 over y plus 1 over z is equal to 0. X minus y plus z is equal to 11. And we are required to find the solutions for x, y, and z. All right, so let's begin by, we're going to use this equation which is equal to 11, and we're going to square both sides. So x minus y plus z equal 11. We're going to actually square both sides, and in doing so, we should end up with basically 9 different terms on the left being equal to 121, which is 11 squared. So let's do just that. So we are left with x squared minus xy plus xz minus, I'm just going to write what I have for the expansion of this right here. Minus yz plus z squared is equal to 121. All right, great. So we could actually group a few of these terms. Now, as we could see, we have an xy here and an xy here. So we could actually group all of these terms. We have an xz, xz, yz, yz, and so on. So let's actually rewrite this equation by grouping the terms which I just highlighted a while ago. All right, so that would leave us with, and I'm going to write the x squared, y squared, and z squared at the front, because that was given in the original equation and that might come in handy. So this is minus 2 so 2xz actually. So 2xz, and this is being taken away, 2yz, and this is equal to 121. All right, so what we could actually do from here, seeing that we know that this is the same as 19 squared, we're going to just write this as 19 squared minus, and from here we're going to actually factor out 2xyz, so 2xyz, and the reason we're doing this is to actually get the fractions 1 over z. So 1 over z minus 1 over y plus 1 over x, and this is equal to 121. Now we could actually, at this point, we could basically find what 19 squared is, and that is 361, and subtract 361 from both sides. So we would be left with negative 2xyz being multiplied by 1 over z minus 1 over y plus 1 over x. So 1 over z minus 1 over y plus 1 over x being equal to negative 240. All right, great. So what we could do now is to divide both sides by negative 2, and, well, yes, divide both sides by negative 2 and also divide both sides by x, y, z. So we will be left with 1 over z minus 1 over y plus 1 over x being equal to 120 over x, y, z. Great. So if we should take a look at our initial equation, one of the equations which was given was this equation, 1 over x plus 1 over y plus 1 over z is equal to 0. So we could actually use simultaneous equation and add both of those equations. So this is 1 over x plus 1 over y. And let's add both of these equations. So 1 over x would actually now become 2 over x. And as you can see, the y terms would be cancelled. And this is now equal to 120 over x, y, z. All right, so we're at a great start. So what we would do from here is to actually multiply both sides of our equation by x, z. So we're going to be multiplying by x, z to actually get rid of the x, z from the right hand side. And on the left hand side, we'll be left with, and also to get rid of the fraction on the left hand side. So we'll be left with 2z plus 2x being equal to 120 over y. All right, so we could actually factor out the 2. So x plus z is equal to 120 over y. All right, great. Now, also from the initial equation, which was given as x minus y plus z is equal to 11. So from the equation which we had x minus y, so x minus y plus z is equal to 11. So we could say that x plus z is equal to 11 plus y. Now, seeing that we have x plus z here, we could substitute 11 plus y, so we would have one variable in our equation. So this would now be 11 plus y being equal to 120 over y. All right, great. And we could actually rewrite this equation and form a quadratic from it. So we would basically have, or let's divide both sides by 2. So the 2 would cancel and we would have 60 on that side. So we'd be left with y squared plus 11y minus 60 is being equal to 0. So that would be our new equation, and we could simply solve this quadratic here. So y squared plus 11y minus 60 is equal to 0. We could use the AC method. So y squared plus 15y minus 4y minus 60 is equal to 0. We could factor out y. So y plus 15 minus 4, y plus 15 equals 0. So y minus 4 and y plus 15. So by taking a look at this, we could see that y is either 4 or y is equal to negative 15. Now, here at this point where we add, we're going to use this equation. However, this time we're going to subtract, so we could actually find another variable. So we're going to subtract at this point. So let's rewrite our equation. 1 over x minus 1 over y plus 1 over z is equal to 120 over x, y, z. And from the initial equation which was given, 1 over x, 1 over y, 1 over z is equal to 0. So we're going to now subtract. So let's subtract and see what we end up with. So now, seeing that we're subtracting, the x terms would cancel, the z terms would cancel, and we'll be simply left with negative 2 over y being equal to 120 over x, y, z. All right, great. So we have this equation to work with, and what I'm going to do is to actually multiply by yz to get x on the left hand side and z on the, well, x on the right hand side and the z on the left hand side. So by yz is what I'm going to multiply throughout. So this would be negative 2 z being equal to 120 over x. All right, great. So negative 2x z is equal to 120. And recall that we had the equation earlier such that, let me use a different color. So we had the equation x minus y plus z is equal to 11. Now, if we were to get x as the subject, we would have x is equal to 11 plus y minus z. And we have two values for y here. So we have that y is equal to 4 or negative 15. So when y is equal to 4, x is equal to 15 minus z, and also when y is equal to negative 15, so when y is equal to negative 15, x is equal to negative 4 minus z. Now, based on this equation that we have, we would use a direct substitution for x to find the value of z. So let's see. So let's use when x is equal to 15 minus 2. So this would leave us with, now this could actually have been simplified, however, it won't really matter. So negative 2, 15 minus z being multiplied by z is equal to 120. Now, if we should actually rearrange this, we would get 2z squared minus 30z is equal to 120, and z squared minus 15z minus 60 is equal to 0. Now, if we look at this and we were supposed to use the AC method, we would realize that it is not possible, and we would hence get rational values for this part of the equation. So we would have to ignore y being 4 as a solution. So this is definitely not one of our solutions. Y can't be 4. So let's use the other solution to see if we could actually get our answer. So when y is negative 15, let me use a different color. So let's use our original. So this is not a solution. So this is not one of the solutions because we're looking for integer values. So let's go back to the equation. Negative 2xz is equal to 120. So negative 2, negative 4, z is equal to 120. And we could actually rewrite this to get a quadratic equation, which would be easy to solve. Minus z squared is equal to negative 60, and hence z squared. So z squared would be plus 4z minus 60 is equal to 0. Now this is factorable using the AC method, so let's do just that. So z squared plus 10 minus 6z minus 60 is equal to 0. So let's take z as our factor, or let's factor out z. So we'll be left with z plus 10 minus 6 equals 0. So z is equal to, so z minus 6, z plus 10 is equal to 0. So z is equal to 6, and z is equal to negative 10. All right, great. So we have two values for z, and we have one value for y. So let's find our value for x. And in finding our value for x, we'll be using this equation. Let me draw a line here. So we'll be using this equation. Bear in mind that y is equal to negative 15, and x plus z is equal to 11 plus y. So we could actually rewrite this equation as x, seeing that we have a negative here, so negative minus negative, so plus 15 All right, so x plus z is equal to -4. So when z is equal to 6, so let me use a different color. So when -10, and when z is equal to -10, all right, so those are basically our possibilities, the solutions for x, y, and z. So solutions for x, y, and z, or the integer solutions rather, would be -10, -15, and 6, and also 6 and -10. So those are the solutions for x, y, and z for this equation. You could use direct substitution to actually prove these solution correct. So if you enjoy these videos, please be sure to leave a like and a comment down below. If you have any other solutions for x, y, and z, I'll be interested to hear what your solutions are. You could also type in the comment any other method that you might have used to solve this problem. So if you enjoy these videos, please leave a like on this video. See you in the next one.